Start. So, good afternoon, guys, and yeah, it's good evening, guys. Right? So, welcome to NEET World YouTube channel and NEET World Institute. So, this class is exclusive for the EAPCET aspirant, right? We have discussed about the things in the last every classes. Like this series is mainly for the EAPCET aspirant, like 2026 for both engineering as well as medical stream. And in this class, which topic we are going to see is work, energy, and power. That is in physics, right? So let's wait for 1 or 2 minutes. The people are joining over here. Okay. Okay. So they are joining over. Let's write on the topic. Work, energy, and power. So in the previous classes we were talking about the work, right? No, so we can get the question in 3 types. Either it's a constant force, variable force, or work done under the graph, like FS graph, no, F and S graph. Like force and displacement graph gives work done, like area under force and displacement. Okay, and then force, like a constant force constant force we have seen, variable force we have seen, and many problems in that cases we have seen, right? And we were discussing about the energies also, like the types of energy, like potential energy and kinetic energy. Then some of this is known as total energy or mechanical energy. And in kinetic energy we were discussing about like the formula is kinetic energy is equals to half mv square, and kinetic energy in terms of momentum, like momentum we know p is equals to mv, so kinetic energy is equals to p square by 2m. So these are the 2 important formula when we talk about the kinetic energy, right? Now we will go for the sums. Before that we will see some forces, like a spring force, right? Spring force, and what is the energy for the spring, right? And how we can calculate for the different kind of forces, and how the forces are acting in different situations. Okay, so we'll see that. So if I talk about a spring, okay, so spring is there. Okay, so let me take initially it's having some distance x. Okay, some distance x. So if I apply either force, like I am pushing the spring or pulling the spring, what will happen? The extension will takes place. Extension will takes place. Let me take this L, and the extension either in this case or in this case, like I am pulling the force. I am pulling the spring by force F. So extension happen is x. So how much ever I am applying the force, that much ever the extension will take place. So can I say that force is directly proportional to x, where F is equals to kx. To remove the proportionality we are adding a constant called k. So with k is nothing but spring constant. So this is about spring force. The work done by the spring is nothing but work done is equals to minus 1 by 2 kx square. So this is the work done by the spring, like work done by the spring formula. Suppose it's a variable if it's a variable, what we can do? So nothing but like from initial x1 to final x2 we will write. Okay. For example, it is minus 1 by 2. Like k I'll write outside. It is x1 to x2 dx. So this is for the a variable. Okay. So this is how we will write the force. Like so we want them for the different conditions of the spring. Okay. You can take a note of this. Okay, so now we'll see a problem. Done. Fine. So here is the problem, guys. Now there is a pendulum, okay? There is a pendulum. It has been taken to the extreme position. It has been taken to the extreme position. If I take to the extreme position, what will happen? It will oscillate, right? It will oscillate. So what is the work done by the tension? Work done by the tension. So work done by the tension in the sense like this is my tension, and obviously it will swing like this, right? No, so displacement will be in this direction. So the angle between them is 90 degree. So I can say that work done by the tension of the spring or the rope will be 0. The same situation we have discussed in the circular path. Suppose object is going in this direction. This is the velocity of the object, like it's going in this direction, right? It's going like this, and the force is in this direction. So angle between them is 90 degree. So for this also work done will be equals to 0. For this also work done will be equals to 0. Now I'll give a situation. Okay. Suppose there is a rope. In this rope there is a 5 kg block and there is 10 kg block. 5 kg and 10 kg. So this 10 kg block will take 2 meters to reach the ground. Okay. So first question work done by 5 kg and 10 kg. 5 kg and 10 kg. Okay. Comma, and by the tension also. And by the tension. So these are the things I need to find here. This is the equation. Okay. Okay, so whenever you are dealing with such type of question, what you should understand is first need to find what is the tension, like free body diagram we need to get it. Okay, so what will be the free body diagram of this 5 kg block? 5 kg block tension will be upward T and this is 5G, and 10 kg block tension will be upward T and down it is 10G, right? So obviously 10 kg block will take the 5 kg block. I mean it is having more weight. It will come down, it will go up, right? No? Yes. So it is going up and it is coming down, right? So what happens here? 10G minus T will be equals to 10A. T minus 5g equals to 5a. When I add both the equation, minus t plus t will get cancelled off. 10g minus 5g will be equals to 15a, where it is 50 by 15 will be equals to a, and this is 25. I mean, not, wait, let me take this. We have divided 50 by 15, it will be equals to a, no? This is 3 times and this 10 times. So 10 by 3 meter per second square is the acceleration. So we have got the acceleration. Now I need to find what is the work done by 5 kg and work done by 10 kg block. Okay, and by the tension they are asking. By the tension in the sense 10 kg block tension and 5 kg block tension. Both I need to get it. So 1, 2, 3, 4 questions. 4 questions I need to get, right? So wait a minute, let me arrange this camera. I guess it's clear now. Okay. Now, yes, now we'll solve the question, okay? Now, what is the thing we can understand here? 10 kg block will take 2 meters to come down, and 5 kg also will go 2 meters up. So, first, work done by, like 4 things are there, okay? Work done by 5 kg, work done by, work done by 10 kg. These two things are based on which force? It is weight, right? Weight. It is weight, based on weight, right? Now 10 kg block is taking 2 meters to come down, which is force is in this direction, displacement also in this direction, because gravity is the thing we are talking. So both are in this direction, theta will be equals to 0 degree. This is 10. What about 5 kg? 5 kg block, 2 meter will go upward, but force will be acting downward. So theta will be equals to 180 degree. 180 degree. So work done will be equals to like force into displacement. What is the force for this? Force for this 10 kg? It is nothing but 10g. And for this it is 5g. So 10g is nothing but 100, no? So 100 into 2 into cos 0 degree, which is nothing but 200 joules. Work done by, this is 10 kg, okay? Work done by 10 kg. Work done by 5 kg will be nothing but F dot D, which is equals to this FD cos theta. So F is 5g, 50, no? 50 into 2 into cos 180 degree. So 100 minus 1, which is nothing but minus 100 joules. So work done by 10 kg block is nothing but 200 joules. Work done by 5 kg block is nothing but minus 100 joules. Okay, this is the answer for the first question. If it is completed, we can go for the next question. Okay, now the tension. Now the tension takes place here. Okay. Okay. Now the 5 kg block, tension is upward. It is displacement is also upward. This is 5 kg and 2 meter. 10 kg block, 10 kg block, tension is upward and displacement 2 meter is downward. Okay, so work done by 5 kg block tension is nothing but 5 kg block tension is nothing but T dot D, which is equals to how much T we got? It is, yes, so acceleration we got right now, we didn't find the T. So what will be the T value? So 10G minus 10A will be equals to T. So 100 minus how much this is? 10 into 10 by 3, which is equals to T. So 100 by 3. So 300 minus 200 is 200. So 200 by 3 will be equals to tension. So 200 by 3 is the tension value. So we can take this tension value and then we can substitute here. Right now? So what will be, wait a minute, let me take this, yes. So what will be the angle for this one? Theta will be equals to 180 degree and the theta will be equals to 0 degree. Right. So 5 kg block no tension, like tension is 200 by 3 and displacement is 2 meter and what is cos? Theta is cos 0, right? So it is 400 by 3, cos 0 is 1. What about the work done by tension, like work done of tension? 10 kg block, which is equals to T dot D. So 200 by 3 into 2. And what is the angle? It is cos 180. Cos 180 degree. So which is nothing but cos 180 is minus 1 and it is minus 400 by 3. So joules, this is also joules. So this is the answer for the given question. So whenever they are asking a question, I need to check that whether what is the forces are acting, or like whatever the forces are acting on a given block and in which direction the force is acting and in which direction the displacement is acting. And then I need to know the angle between them. Okay. Done. So can we go for the next one? Okay. So now we'll see some EAPCET questions. Okay. Now the first question. Okay. A body constrained to move, constrained in the sense it is restricted to move in some direction they have given. So constrained to move in y direction is subjected to a force is given by F is equals to 2i cap plus 15j cap. So F is equals to 2i cap plus 15j cap and then plus 6k cap Newton. Okay, it has been restricted to go in only one direction, that is y axis, that is y direction. What is the work done by the force in moving the body a distance of 10 meter along y axis? Moving the body 10 meter, so displacement is 10 meter in y axis. So what is the work done they are asking? What is the work done? Right? So whenever we are talking about a restricted, like constrained manner, okay, so which means like they have given in some direction, okay, y axis. So I can write this as 10j cap. So remaining thing, that is 0i cap, 0k cap, right now. So displacement is nothing but 0i cap plus 10j cap plus 0k cap. Got it? This is my displacement. Now work done, W is equals to F dot D. So what is F? 2i cap plus 15j cap plus 6k cap dot 0i cap plus 10j cap plus 0k cap. So I cap and k cap, no use of that, right? Only j cap. So 150 joules is the answer. This is how we will solve the such type of problems. Okay. Done? Okay, next question. Right? So next question is, yeah, a force F is equals to kx square. A force F is equals to kx square, okay, acts on a particle at an angle 60 degree with x axis. Acts on a particle at angle 60 degree with x axis. The work done by displacing a particle from x1 is equals to, x1 to x2. Displacing a particle from x1 to x2. So this is the question. Okay. So force has been given like this, like F is equals to kx square and displacing a particle from x1 to x2. So I can say that work done will be equals to integral of x1 x2 f dot dx, f dot dx, right? So this is how we will do the questions, right? Yes, like don't think that like F is equals to kx square, like it has been, it's given in terms of spring constant. No. Like F is directly proportional to x, F is equals to kx, okay? But if they have mentioned in the question it is a spring force, so then you can take work done by the spring. They have mentioned work done by the particle and force has been applied, F is equals to kx square, right? And it has been moved from x1 to x2. So W is equals to x1, like integral x1 to x2 f dot dx. Okay. Now what I can do here? X1 to x2. What is force? Kx square dx. So kx square, like k is a constant. No, k is constant. So I can say k I can take commonly, I can take outside. So x1 to x2 x square dx. So integral of x square is, like integral of x power n is nothing but x power n plus 1 by n plus 1. Okay. So k into, it is x power 2 plus 1 by 2 plus 1 from like lower limit is x1 and upper limit is x2. So it is k x cube by 3 from x1 to x2. So final answer will be k of x square, x2 cube by 3 minus x1 cube by 3. This is the answer. Okay. Okay, so next question we will see. Next question. Okay, so it is a different kind of question. Okay, a force acts on a 3 gram particle. Force acting on mass they are given is 3 gram particle. Okay. Such that its position x is equals to such that its position x is equals to 3t minus 4t square plus t cube. Okay, where x is in meter and t is in seconds. The work done work done during first 4 seconds. So work done during first 4 seconds they are asking, right? So first thing, what I can do here, I can differentiate this and I can get acceleration. First of all, work done is nothing but work done is nothing but force into displacement, right? So force is nothing but it is mass into acceleration and displacement. Okay, D. So mass is there. Okay, fine. What about acceleration? What about displacement? Displacement I need to get it. Acceleration also I need to get it. If I differentiate this, I'll get velocity. Again, if I differentiate that velocity, I'll get acceleration. Right? No. So dx by dt is nothing but velocity, which is equals to 3 minus 8t plus 3t square. And next, dv by dt is nothing but acceleration, which is equals to minus 8 plus 60. So at t is equals to 4, they have given no 3, so t is equals to 4. So t is equals to 4 in the sense I can substitute the values here in x and a. So what I will get in x? X is equals to 3 into 4 minus 4 into 4 square plus 4 cube. 4 cube. So this is 4 is 12 and this is 16. 16 4s are 32 and 64, right? Minus 64 and this is again 4 cube. So I can say this and this will get cancelled off. So x is equals to 12. X is equals to 12. Right now? Am I right? Okay, fine. What about acceleration? A is equals to minus 8 plus 60. So minus 8 plus 6 into 4, which is nothing but 24 minus 8, 16. A is 16. So now I can substitute the values over there. Okay. So first of all, I need to find force. Force is nothing but mass. So mass is 3 gram. 3 by 1000 into 16. So 16 3s are, it is 30 to 48, right? 48 divided by 1000, which is nothing but 0.048. And displacement is 12. So work done will be equals to 0.048 into 12. I'll get the work done final answer. Okay. Done. Can we go for the next one? Okay, the next question. We go for the next question? Fine. So the next question is, a rope is used to lower vertically a block of mass m by a distance x with a constant downward acceleration g by 2. G by 2. Okay, so there is a block and okay, let me write. There is a rope and there is a block and which have mass m and it's going with the acceleration g by 2, that is a. Okay, so work done by the rope on the block is okay. So it has been travelled for a distance x they have given. Work done by the rope on the block. Work done by the rope on the block in the sense I need to find what is the tension over there, right? So free body diagram will be looking like this now. So m and this is my t and this is my w. So going downwards, right? So what will be the equation now? Yes, w minus t will be equals to mg. So w is nothing but m and g I'll write as it is minus t will be equals to m. Sorry, a is nothing but g by 2. So mg minus m into g by 2 will be equals to t. So t will be equals to mg by 2. Okay, fine. Mg by 2 we got. Now what we will do? Work done will be equals to force into displacement. So F dot d. So Fd cos theta. So this is my d and it's going downwards. Tension is acting upward. Angle between them theta is equals to 180 degree. Right? So what is tension? Mg by 2 and what is displacement x and cos 180 degree, which is nothing but minus mgx by 2. This is the answer for the given question. So this is the answer for the given question. Got it? Done. So can we go for the next question? Okay. So till now we were discussing about the rope and the tension and the weight, etc. Right? Now suppose they are asking the question in terms of friction, how we can deal with that such type of question. So work done in moving a body of mass 4 kg with uniform velocity of 5 meter per second. So mass they have given us 5 kg and uniform velocity 5 meter per second. Right. Next they have given that for 10 seconds it has been moved for 10 seconds. Okay, on the surface of for 10 seconds t is equals to 10 seconds of the surface of mu is equals to 0.4. Mu is equals to 0.4. So what is the work done? Okay, and one more thing they have given that use g is equals to 9.8. Okay, g is equals to 9.8. Okay, this is the thing they have given. Now what is the work done they are asking? The work done they are asking by the friction. No, mu is they have given. No, mu they have given. Okay, work done by the friction. What is the formula? So friction is nothing but mu into n. Right? Force, that is F is equals to mu is 0.4. Okay, fine. What about n? N is nothing but mg, right? So mass is 5 and g is 9.8. G is 9.8. Okay. So to remove this points, I can do that. 5 into 4 into 98 divide by and 1 to 100. Right? 100. Okay. So this is 20, no? So 20 into 98 divided by 100, 10 and 10 will get cancelled. 196 divided by 10. So 19.6 is the F value. 19.6 is the F value. Now what is the thing I should do now? Okay, so they have given V is equals to 5 meter per second, T is equals to 10 second. So many of you are having a doubt, sir, you got the force value, what about the displacement? So I can use velocity is equals to displacement by time. So velocity is equals to displacement by time, where displacement is velocity into time, right? What is velocity? 5. What is time? 10. It is nothing but 50 meter. Displacement is 50 meter, force is there. So W is equals to F into D, where F is 19.6 into and this is 50. Right? So what will be the answer? So 19.6 like 10 I can take it out, 196 into 5. 196 into 5. So what is 196 into 5? What is the value? It is 980, right? 980. So 980 joules. Got it? So if we have used 10, so for the calculation purposes, okay, if the option is given like 980 or 970, 960, like that, some other options, okay. Now we have used 10. If we use 10, what will be the answer we would have got here? It is 200, and here also, here we would have got 1000, right? Yes, fine. So 1000 in the sense which is near 2980 is nearest value. So I can get the answer, right? 980. Got it? Okay. So now we'll see a topic. Okay, wait a minute. Let me arrange the camera. I guess it's clear. Okay, it's clear. So next topic is conservative and non-conservative forces. So conservative and non-conservative forces. So what is the meaning of conservative or non-conservative force? So conservative force, it is first point, depends on initial and final position. Okay, this is the first point. Second point, it doesn't depends on the path followed. Okay, doesn't depend on the path followed. Okay, whereas the non-conservative, it is a vice versa. It doesn't depend on the initial and final position, it depends on the path followed. So for example, what is the examples I can say for this is like gravity, I can say, right? Gravity. When I talk about it depends on the path travel. I can say example, friction, right? Friction is one of the example for non-conservative force. Example for conservative force is gravity. Gravity, initial and final position only. It doesn't depend on the path how it has been traveled. But whereas non-conservative depends on the path travel. That's why the example is friction we have given here. Okay. Here example is gravity. Right. Got it? We'll go for the next one. Okay. So now we'll see a problem. We'll see the problem now. Okay. So first question, calculate the work done to displace the particle from 1, 2 to 4, 5. So I need to find the work done. Okay. From 1, 2 to 4, 5. Okay. And if f is equals to 4 I cap plus 3 j cap, f is equals to 4 I cap plus 3 j cap. This is first question. So force is given in terms of I cap and j cap, and points are given in terms of x, y, x1, y1, x2, y2. Right now? Excuse me. Okay. Now work done will be equals to f dot s or f dot d, whatever it is. Okay. Now the points, if I calculate, if I see here, no, it's a variable points. It's varying. Yes, no, it's varying. So what I should do now? What's the thing I can do here? Okay, fine. So it's varying with time they have given, right? So W is equals to integral of f dot ds. So if I talk about for I cap, no, x axis, let me take integral from 1 to 1 to 4 fx dot dx plus integral from how much 2 to 5 fy dot dy. Okay, got it. Now what is fx? It is 4i. So 4, no. So 4 with respect to dx I need to integrate from 1 to 4 and plus, and this is how much? 3, no. This is 2 to 5 3 dy. If I integrate this one, I will get 4t from 1 to 4 plus, and this is 4x, no, 4x and 3y from 2 to 5. Got it? So if I substitute this one, now 4 into 4 minus 4 into 1 plus 3 into 5 minus 3 into 2. So how much? 4 16 and minus 4 plus 3 5 15 minus 6 12 plus 9, which is nothing but 21 joules is the answer for this question. So whenever they give a point and they are mentioning that forces in x, I cap, j cap or k cap or x axis, y axis or z axis, okay, this is how we will proceed the problem. Okay, can we go for the next question now? Okay, so the next question is, an object is displaced from a position vector. So now they have given the position vector, that is r1 is equals to 2i cap plus 3j cap meter, and r2 is equals to 4i cap plus 6j cap meter. Okay, position vector they have given, and force is given as 3x square I cap. F is equals to 3x square I cap, then plus 2y j cap Newton. So what is the work done? So this is one type of question. They have initially, previous question they have given points. Here they have given position, right now position. So here also the same procedure we will use. So W is equals to integral f dot ds. So integral from x1 to x2 f dot dx, that is fx. Okay, so 3x square will get. Next plus y1 to y2 fy dot dy. Right, so the points are 2, 3, 4, 6. So let me write that. From 2 to 4, what is fx? It is 3x square with respect to dx plus integral from 3 to 6, and this is 6, 2y, no, this is 2y dot dy. That's it. So we have written the equation. Now only calculation is remaining. So what will I get? 3x cube by 3 from 2 to 4 plus 2y square by 2 from 3 to 6. So 3 cancel, 2 cancel. So x cube, no, like 4 cube. So 4 cube minus 2 cube plus this is one term and the second term. 6 square minus 3 square. Right? So 4 cube. 4, 16, 4, 64. So 64 minus 8 is a 2 cube, no, 8. Plus and 36 minus 9, no, 36 minus 9. How much will I get this one? This is 56 I will get. Okay, 56. Plus this is 27. How much? 76 and 7, 83 joules. So this is my work done when they are given in the kind of position vector. Okay, they are given in the kind of position vector. So in the previous case they have given in terms of points like 1 comma 2 to 4 comma 5, and we have derived like this. And in the next case they have given in terms of position vector and force they have given, and we have derived in the same kind, like the thing I need to conclude that this is 2 comma 3 and this is 4 comma 6, right? Understood? So is there any doubt in this now? Okay, so with this we'll conclude today's class, and we'll see some more topics and questions in the next session. Okay, bye bye guys, we'll meet in the next class. Bye bye.